Here's example 3. For the following function, a, give the coordinate of any point of inflection. Point of inflection. How do we find it? We set the second derivative equal to 0. And then when you find the value, we have to check the concavity to the right of it and to the left of it. So I'll show you how to do this here. Okay? So first, to get the... Let's restart this. Oh, everything just... Oh, my writing's gone. I'll have to start over again. Okay, so find the first derivative first. 3x squared plus 6x minus 9. But if you want to find any point of inflection, you need the second derivative. So go on one more step. 6x plus 6. I think I recognize this function. Isn't this from example number 2 or 1? I think so. Okay, so let's find the point of inflection. To find POI, or potential POI, point of inflection, set f prime of x, f double prime of x equal to 0. And solve for x. I should add potential. Because even if it comes out to, even if you get an x value, that makes the second derivative 0, it may not be a point of inflection. So I'll show you how to make sure that it is a point of inflection. So set it equal to 0. 0 equals 6x plus 6. If I solve this, wouldn't that be x equals negative 1? So there is a chance that a negative 1 is the x-coordinate of point of inflection. To make sure it is, what you will do is you'll put negative 1 in the middle, and you will go ahead and check the concavity to the left of it and to the right of it. So the second derivative is 6x plus 6. You plug in a number that is bigger than negative 1 into the second derivative. I'll pick 0 because 0 is bigger than negative 1. If I plug in 0, I get that the second derivative is positive, which means the graph is concave up. So I'll say this is concave up to the right of negative 1. I do want to see concave down for the other interval. So are you ready? Let's plug in something else then. What is a number that is smaller than negative 1? I will pick negative 2. That will be 6 times negative 2 plus 6. And that is negative 12 plus 6. So that's negative 6. So negative second derivative means this is the concave down interval. Concave down. So if the concavity to the left and the right is different, it was down to the left, up to the right, we get to say this is the x value of a point of inflection. So now I need to find the y value because they wanted the point of inflection, not just the x value. So, hold on. I'm ready to plug in x equals negative 1. So what is the y value? F of negative 1 is negative 1 cubed plus 3 times negative 1 squared minus 9 times negative 1 minus 13. All right, let's find the y value to be negative 2. So we found the point of inflection is negative 1, negative 2. You need to check the concavity to the left and right of it. If you skip this work that I did in blue, okay, this work you see, that's not enough. If you don't do this work and just tell me that, oh, it's the point of inflection because the second derivative was 0 at x equals negative 1, that is not enough. You need to show me that the concavity changes to the left and right of it to say it is a true point of inflection, okay? So I think they're going to ask us for the... I'm just trying to make the room for the next part. The next part is B. Identify intervals where the function is concave up or concave down. Oh, we did that already. So let me go ahead and write the final answer. Concave up on -1 to positive infinity, and concave down on -infinity to -1. So we had to tell them the concavity of this graph, but that was part of my work while I was trying to find that point of inflection. So that's it for this example. I believe I will come back and do example 4 in another video.